prefixes is actually the rightful owner of the whether that network is actually the rightful owner of that set of prefixes. So basically, when we say network, that's an autonomous number system, right? And again, to highlight, we assume that everyone is correct, right? So internet is basically a mutually effort, and we expect, like, if I have different neighbors on the internet, means I expect all my neighbors to be honest. They only send me the good routes, not some fake routes, right? And as I said, routing is variable. The way you look at a routing table from one point on the internet may be different from what you look at on the other side of the world, right? So there is different routing location outcomes at different locations. So as we saw in the picture at the beginning of the slide, we had this maps showing like different routes to a destination, right? So even at one single reference point, you can have multiple routes to that destination, right? And it's to us to choose like which is the best route to that destination, right? And we also talked about this one. So routing works in reverse. So whatever you send out on the internet, so if you're sending a set of prefixes on the internet, means like you're hosting some kind of services on those prefixes, and you're basically welcoming the traffic into your network, right? So anything that's accepted so again, why we will, even though we talked about like a few things, right? So there is no reference point. We just assume that everyone is good and honest on the internet, but still we see there's routing incidents, right? And you can see there's RFC 3514. There is no evil bit, right? So you just cannot send a routing update with an evil bit, right? So a bad routing does not identify itself as bad. So we don't really know, like if someone is announcing me something, how do I know it's good or bad, right? And we always expect our neighbors to send us good updates. But we've seen already a few examples like how even a slight configuration mistake can cause disruption in your services in terms of routing, right? So our objective here is like how we define good updates, good routing updates, right? So this is the thing that we are covering for the rest of these slides. And just so bad to do bad in the routing, right? So one of the things I think all of you are very well aware is filter, right? So basically you're trying to filter whatever announcement you're sending over the internet, you filter it out. Whatever announcement you're receiving on the internet, you filter it out, right? You just do not want to send updates that are not good enough, right? So for filters, you can apply prefix filters. You can do on the BGP because BGP is a path vector protocol. You can apply AS path filters, right? So basically, AS path filter means like what set of AS number should be basically seen in that path for that particular prefix that you see, right? And there is also default rejection. I think this is very important for like networks if they're trying to filter out anything over the internet, right? Because if you just accept the default, means like you're accepting over anything over the internet, right? So if you want to be specific and filter out certain prefixes or networks over the internet, means like you have to get away with this, right? So how do we develop the filters is one other thing, right? So we talked about prefix filter, we talk about AS path filter, but how do we know like what are the set of prefixes that we need to filter, or what are the AS path, what AS is in the path for the prefixes that we need to actually accept, right? So one of the current practices is like you could do a letter of authorization check, right? So basically someone is sending you a letter in the cover head, name of the organization, like telling you like, hey, this is the list of prefixes that I want you to accept as my BGP neighbor, right? So there can be actually peering or transit. So does anyone know what peering and transit is? So peering is basically a settlement free most of the time, right? But sometimes also paid. But transit is like you basically a customer of the other network, right? But if you're accepting something on the internet, means like you can also receive routes from peering, you can also receive routes from transit. So you need to be able to filter both the peering side and the transit side, right? So one of the examples is LOA check, right? So we have letter of authority, and with there is the IRR database itself, right? So we can just do a whois on the IRR database and see like who that particular prefix belongs to. And there is also called RPSL, that is a specific language that you can use with certain tools to actually develop your filters. Right, so I think this is clear enough at the back. So basically we have a prefix here 202.125.96.0 /24, right? So if I do a who is dash h who is the ethnic.net, then it would show me the range of that IP address. And on the other side, right hand side, you can see the route itself. That's a /24 network, and that belongs to the origin is number 131107. So basically, this means that this /24 network is 131107, right? So that's what's defined in the route object, right? And this belongs to Ebenic training. So this is one of the ways you can verify the holder of a resource, right? So you can just say that this particular /24 network belongs to Ebenic training, and it has to be seen on the internet with the origin ES number of 131107, right? So this is easy. You can just go to your IRR database and do a whois query, then you should get an answer like this. And there's another thing, I talked about this earlier, right? So you can also send a letter to your peers or transit to accept a certain set of prefixes that you want to advertise to them on the BGP session, right? And you just tell them that, hey, this is the origin ES number, and you should be able to accept this prefix, right? And there is, you can also query other internet routing registry. So along with Ethnic, there exist so many in the IRR database, right? So there are so many databases out there on the internet that you can query to for knowing more about a particular prefix on the internet, right? So in this case, I am querying basically the RADB database, right? So 61.45.248.0/24 belongs to Ethnic training, and it should be seen with the origin AS number of AS13533, right? So uh, we use Ethnic database in the earlier case. Now we're using something else. So RADB, right? And also you can query it by AS numbers, and AS number basically tells you that which organization that AS number belongs to. And down below you can see that import and export policy. That is basically the routing policies defined by that network, right? So basically you can define this information when you create the route objects, right? So you basically you can have this information, uh, the import and export policy defined. And there is also other tools that you can use. So one of the most popular tool that is in use is BGPQ3. So you can filter out route advertisement not described in the registry. So it has a certain set of flags that you can use and create a filter for yourself, right? So if you use a S flag, then you can tell that, okay, hey, Epinic, give me the list of these prefixes for this particular S number, right? So it will just generate you a list of prefixes that you want according to your router. So there are different set of routers, for example, Cisco, Juniper, Bird, whatever you use. I think there are around like 6 to 7 kind of routers output that it can generate, right? And you can just copy it and paste it into your filters to filter out the prefixes, right? So it's easy. right? So you can also do it based on AS set, right? So on the right hand side, you can see that DruckNet has an AS set of AS DruckNet dash transit, right? And Superloop is another provider in Australia. They also define. You can also define uh, the field the AS path. You can just generate the AS path based on that command over there and using the AS set, right? So one of the things we saw like two different IRR database, right? So the problem with IRR is also like there is no single authority. There operate so many databases, and you can query all of them, right? So even though you want to rely on one particular database, doesn't mean that it has to be perfect and accurate, right? And actually, there is no one single authority, right? Everyone is free to operate their own RR database, right? And the few things that you need to consider is like if the entry on that database itself is correct or not, and if the entry that's seen on that database is actually the entry at this point in time, all right? So it has to be up to date as well. And if two IRR database contain conflicting data, then what is the one I trust? That's one of the big questions that you need to ask yourself, right? And again, there is problems with like incomplete data. Some on database do not have this complete information, and you just cannot rely on that one particular database to pull the filters, right? So if route is not in the IRR, then is the route invalid or IRR is just missing the data. So there is also a problem with incompleteness. And another thing is like scaling, right? So now you have like whole set of database itself, and you have this list of like 10 million prefixes, and you want to go ahead and or at least like 70,000 72,000 AS numbers on the internet, and you want to go and query for each one or each and every of them, means you have also a scaling problem using this kind of tools, right? So these are the problems that we basically see with IRR database, right? And we just do not want to rely on one particular database itself. So what we really need is like some kind of tool that actually fetches all the informations together and gives us in one place. That's what we need, right? So that also helps us in scaling, and also eliminates problem of having this incomplete data and conflicting information on different databases itself. Yeah, so when you use, you could actually do a lot of automation, right, for creating your filters. Uh, but again, it's only good as the correctness of the IRR entry itself, right? So also at times we might need to do manual overrides sometimes, right? Because um, you need to verify the holder of the resources. And as in the previous example, you could also specify sources. Say, for example, whatever comes out in the epinic region is like, you can tell that epinic is the authentic source because that's where all the route objects is created, right? The first time uh, you go and ask for a resource at epinic, right? So whatever comes out of the epinic region means like you can just do a S flag in BGPQ3 and then generate the filters, assuming the mirrors are up to date, right? So for us in the epinic region, it's always good to use the epinic database because that's the authentic source, right? But again, like automating the filters is tedious task itself. So again, there comes the problem with scaling itself. And over the internet, you just do not see the prefixes from the epinic region, but you see also prefixes from outside the epinic region, and you need to filter them all out, right? And there is a problem. So yeah, so talking about robots, we could use digitally signed objects um, to authorize whatever we see on the internet, right? So it's basically a combination of private and public key in cryptography. It's general cryptography techniques. So there is a private key that actually you can use to sign all the resources that you obtain out of your registry, right? And any other networks on the internet can use your public key to validate that the resource actually belongs to you, right? So it's just a um, private public key combination that we use in certificates. Say, for example, in SSL certificates, it's a similar technique. So if the holder of the resources has a private key, it can actually sign the resources, right? So if I have a set of IP addresses, IP prefixes, AS numbers, and I can just tell that, okay, hey, this is the list of prefixes, this is my AS number, just sign it off and publish it on the internet. And any other network can just download that information and use my public key to verify the resources. It's easy. Now you don't have to worry about anything, right? So again, when we look at the delegation hierarchy, we have IANA, which actually distributes the uh, prefixes to the RIRs, right? So in our case, it's APANIC in the APANIC region. And there are national internet registry, local internet registry that can be run by big ISPs, telecoms within the country itself or the region, right? And there are end holders. So um, the RIRs, actually in our case, is in APANIC. We can get the resources directly from APANIC. So we can just be the end holders, or we can rely on national internet registry or local internet registry and get the resources from them as well, right? So this is how we have to have this chain of trust, like, so we say example, I need, someone has to be able to verify, okay, this belong, whatever resources I get from here means I have, the other person on the internet has to ask this particular registry, like, okay, if I'm the owner of this particular resources or not, right? So it all depends on like the hierarchy of certificates that comes along with the delegates and stuff. So yes, so there are 5 regions: APIN, AFRINIC, APINIC, LACNIC, RIPE, NCC, right? So in our case, in the APINIC region, APINIC would be our certificate authority. And if we are taking the resources from the National Internet Registry, then they would be our certificate authority, right? So again, the chain of trust would be like from here to here. It would define, and if I'm getting the resource directly from APINIC, means I have to go through here. If not, then I have to go through from here to the National Internet Registry or the local Internet Registry. So what I have is like they have a self-signed root certificate for all the resources they have in that in their registry, right? So APINIC has a set of block of IP address. So for all those resources, they have a self-signed certificate, and they are particularly called as the trust anchors for that system, right? So the root certificate, actually they sign the resources for the end holder allocations, and what it does is actually bind the resources to the end holder's public key, right? So if I publish a public key on the internet, someone has to verify that public key actually belongs to me, right? And this is what the certificate authority does. And any attestation signed by the end holder's private key. So if I have any set of resources that I use my private key to sign it off and publish it on the internet, right? Now it can be validated up to the chain of trust, because someone else can go and ask the CA itself, like if this public key is trustable or not, and they can use my public and private key combination, public key to verify the resources I have, right? So I, as a resource holder, I use my private key to sign all the resources, publish it on the internet. Someone else's from third party comes to me on the internet and uses my public key, verifies it to the root, and grabs the information out of the info, information I have published on the internet, right? So this is how it works, and this is similar to how it works in case of digital certificate stuff. So actually, I'm going to show this demo after this talk, because I was looking at this two two links here, and they were not actually working this morning. So maybe I'll show it after to you. But I have yeah, I'll show it to you after to you. Just like how the certificate looks like. Right? So it's nothing more details that I need to cover in here. Right. So when you see the resource certificate, it actually is a X.509 certificate. So according to the RFC 3779 extension, it finds a list of resources, IPv4, V6, and AS number to the subject of the certificate. That's the private key holder, and that's me, right? So because I'm the resource holder of the IP prefixes and the AS number. And also it contains information like subject information access. So basically contains the URI with tells me that where that object is located, right? So in my case, it would be the APANIC database, right? And there is this my public key, and it's all signed by my parents' private key. So in my case, my if I'm getting a resource directly from APANIC, means APANIC is my parent, and this they sign it all this information together. Right, so the whois.bgpmon.net you actually used to work before, but now it's been taken over by Cisco, so it doesn't work anymore. Right, but you can see on the right hand side, you see like what kind of algorithm it uses, and here it's a list of. Is it clear at the back? What is- okay, I think this is good enough, right? So basically, it's tells me like list of AS number I have in that certificate, and also the IPv4 and IPv6 prefixes, right? So all of this information is actually shown, and there is also this public key info, like, and what the kind of algorithm it uses, the validity itself, and there is also this URI uniform resource identifier, right? So it's a APANIC repository, right? So basically, a certificate would contain all of this information. You can actually go to this link and have a look at the certificate on your terminal. So let's talk a little bit about like certificate, right? So how we can prove it. So when an address holder A, that's the internet registry, allocates a resource IP addresses and AS number to B, that's the N holder. So it's me, like when I take a resource from the API, right? So A basically issues a resource certificate that binds the allocated address with my public key, all signed by my certificate authority private key. So my root would sign everything, all the public key itself, and also the resource itself. And now the resource certificate proves that the holder of the private key is B, and the legitimate is actually the legitimate holder of the number resources, right? So it's basically trying to like validating whatever information I publish on the as objects or for the resources is basically trying to verify uh, using my certificate authority and my public key, right? So what I can do now is like, and now I can sign everything, all my resources using my private key, which can be validated by all third party. And what I can actually do is like for ROA, I can actually tell that the address holder can authorize a network AS number to originate a route, right? So I can tell that, okay, this prefix has to be seen on the internet from this particular AS number, right? So I can sign that information, and I can use my private key to sign that information. And someone else can use my public key on the internet or the registry itself, and they can verify my signed resources, right? And that's what we call route origin authorization, right? So basically, in a row, I have a prefix and an origin, right? So it's a digitally signed object, right? And it can be cryptographically verified. That's what we talked about already. So basically, I have a prefix 203.176.32.0/19. And another thing I define here is the max length. So the maximum length of this prefix that can be seen on the internet routing table is up to /24. Anything greater than /24 doesn't belong to this resource holder. That's what we say, right? And here I tell that, okay, this is my origin AS number. So anything from /19 to /24 seen on the internet with the origin AS number has to be valid, and this belongs to this AS number, right? And again, you can see that multiple ROAs can exist for the same prefixes, right? So if you are an organization, you have your own IP addresses, prefixes, but you're not doing any kind of routing, then and you rely on someone else to do the routing for you on the internet, means like you need to create a ROA for that particular network as well, like who is originating that prefix, and you need to give that information over here as digitally signed object for others to verify. All right, is this okay? So yeah, I actually forgot to mention I have a few gift here, right? So anyone who is asking questions or answering some of my questions will actually get some gifts. Yeah, I just give an example, right? So you are a small network, right? So you don't have your capacity to do your own routing, right? But you own a resources out of the internet, and you're relying on some upstream provider to advertise this resources on the internet. Means you can have this upstream AS number bind to this particular prefix, and you can announce it over the internet. And anything um, that's seen on the internet with that particular AS number from the upstream AS number can also be shown. Right? And there are also cases like proxy route objects, right? So someone else's, like for example, Anycast. So you do your announcement from different locations using different AS numbers, then you need to have that information also binded here in the digitally signed object, right? So if you're using different AS number, yeah, yeah, it can be also the case. Sorry. Yes. Yeah, but in that case, you're not doing the routing by yourself, right? So you're not doing any kind of routing by yourself, but you're relying on someone else to do the routing for you. Then also you need to create the row in the system. Uh-huh. Uh-huh. So you need to do that actually. Yeah, that's what we said. Like same prefix can have multiple rows, like different origin OS numbers. Well, that you trust on your upstream provider, right? So you know that he's the one always doing the routing for you. Then you definitely need to create you need to have that origin AS number information on that for that digitally signed object for that particular prefix. No, I mean like for verification, you have that same kind of services that you taking from those two providers, right? So it basically like now you'll see like two different paths, but two different paths are valid. That's what the ROA can say. It doesn't affect the routing. I mean like the traffic flow itself, right? So basically you're only telling that, okay, these two paths with two different origin ES number, if you see on the internet, then you should accept it. That's the information you're telling on the internet using this kind of mechanism. Yes. Again, again, yes, yes, yes. So when you're doing like multiple rows, you are actually creating two different objects, right? So you can actually advertise. I mean, like the same prefixes with different origin AS number. You can actually advertise. There is no harm in advertising. It's the trust you have with your upstream provider, right? And with doing this, you're not influencing any routing on the internet. You're telling just people that, okay, here, this is two origin AS number with this for this prefix, and you should accept it, right? That's the information you are giving out on the internet. So what can RPKI do? So yeah, we solve the questions like who is the legitimate owner of the addresses and identify which AS numbers have the permission from the holder to originate that IP address. So you as a holder has to tell what origin AS number, what prefix should be announced, right? So even if you create multiple row, if you have to create multiple layers, you are the one to do it, right? And one of the good things about this is like it can prevent drive hijacks, misorigination, and misconfiguration that we talked about in the first half of this session. So let's look at the RPKI component itself. So the RPKI component is there is a issuing party, right? So there is a certificate authority, that's the internet registries that issues the resource certificate to the end holders, right? And the end holder and the CA actually publishes the route objects, ROAs signed by the resource of the certificate holders, right? So I sign my resources and I publish it in the internet registry, right? So basically it's the internet registry that does it for us. So it has to be accessible on the internet, right? And there is this so in my APNIC, so you basically have this route object, right? And you turn on the RPKI engine and it does some cryptographic functions on it and actually it sends it out on the repository for others to download the resources, right? And there is also called relying party. So these are the validators that we are actually going to build in our lab. and they gather the route origin authorization information from the distributed RPKI repositories. So there can be multiple RPKI repositories, right? So we need to be able to download all the information for the whole of the internet. Right? So on the internet, there are 72,000 AS numbers and around 10 million prefix IPv4, right? And also IPv6. You need to do that all, right? So validate each entry signature against the trust anchor and build a validated cache. So trust anchor is like for all the resources that belongs to the APANIC region, APANIC registry is the trust anchor, right? And for other regions, there is also trust anchor like AFRINIC, ARIN, right? There are 5 different tabs, trust anchor location. So yes, the protocol that is used is rsync and RRDP. So basically you have a validator and it's fetching all the information from different repositories over here and using this either of these two protocols, and it's building a validated cache. So this is something that you're building in your own network and letting your routers in the network to query that validated cache and build your filters. So now it's easy, right? So you don't have to worry about like scaling because you've got all the information into one single point now. So again, there are two different models for the RPKI services. So there can be a hosted model or a delegated model. So the routing registry APANIC can be like the hosted model runs the CA function on the member's behalf, right? So it basically manages keys, repos, and generates the certificates for the resource delegation. So you can actually do it from APANIC direct itself. Or if you have a local internet registry or a national internet registry, for example, in case of CERNet, I think you have CERNIC, right? So CERNIC, you can go with this model, right? So this also becomes the CA and operates the full RPKI system. So you have your own repository, right? So like JPNIC, TWNIC, CNNIC in China, I think IDNIC is also already operational. So you can have either of these two. Or if you're a large service provider, you can also have your own RPKI system, right? Because you are also giving away the resources to your customers. So you can have this RPKI system into your network itself, right? So it basically like which model you want to choose. So we talked about the ROA, but we have not talked about validation, right? So you can see here there is an AS number 17821 and it's originating a /48 prefix 2406 6400 /48 and it's announcing it to its peer 6550 which further propagates it to 6551 and I. And when I see this route over from here, I see the AS number in the path, right? So 17821 is actually the origin of that particular prefix, IPv6 prefix. Now, some bad actor can also come from another AS number and simply tell that, okay, 2406 6400 /48 actually belongs to 6552. You can tell that, right? And propagate it through this peer and up to me. And when I look at here, I see a sort of path, right? So we already told about like sort of path. Then I always send my traffic over here instead of here, even though that is the legitimate owner. Now, to prevent this case, we actually use route origin validation, right? So in the RPKI component itself, there is this global RPKI system, right? So there are like different set of RPKI repositories that you can actually query for the information for the ROAs, right? So in my network, I run a validator. So this is something I run inside my network. And what this validator does is like it uses rsync and RRDP to actually fetch the information from the global repository, right? So now it tells me that, okay, this actually from /32 to /48 actually belongs to 17821, right? So now I have that information on a validator. Now what I do is like my validator and my router, edge router, peering router, I actually run a session between them so that a validator, whatever information the validator has, a verified information can actually be sent to this router. Now this router can actually be able to decide, okay, this is a bad update and that's a good update, right? So yes, the first one is valid because that's the legitimate owner of the prefix. That's what we get the information from here, right? From /32 to /48 belongs to actually say 17821. And if it comes from any other AS number, then 17821 means it's invalid, right? So even though the case here is like the sort of path, what you can do is like on a router, you can tell, hey, I'm blocking all the invalid, I'm rejecting them. Now, even though path is shorter, you would not actually send the traffic out to the bad person on the internet, right? So you would actually send the traffic out to the valid address, right? So this is how the mechanism works, right? So everything is built here, and all the cryptographically signed information is stripped off, and you have this clean cache over here that actually talks to your router, edge router, and your edge router actually has this information over here, and it can influence the routing decision, right? So what I can tell here is like, hey, anything invalid, I just need to drop it off, and I only accept the valid routes, and all the traffic would actually start passing through this. Right, so router fetches the raw information from the validator RPKI cache, and BGP checks its received BGP update against the raw information and labels them. So labeling means like whether the route is valid, invalid, or not found. Right? So yeah, so valid means that the prefix and the ASPR is found in the database. Okay, I'm able to validate it. Invalid is prefix is found, but the origin is wrong. So that comes with the bad origin, just like in the example we had. Right, or the prefix length is longer than the maximum length, right? So in this case, we actually told the prefix length has to be up to /48 from 32, right? So anything bigger than /48 is not to be accepted, right? Well, it's a rule, generic rule on the internet that anything greater than /48 is not to be accepted on the internet, but at least you can define that maximum length and see like whether that prefix is invalid or not, right? So there are two cases. One is the origin AS number is wrong, and another is the maximum AS maximum length of the prefix is longer than what's defined in that digitally signed object, right? And the third case is not found, no valid row for that information, perhaps not created, right? Now, as an operator, what do we do with this? Right? We can tell that valid is something good, okay? And invalid is actually a bad thing, right? Because that can be with a bad intent also. We already talked about it. We gave a few info, like there are two cases. There can be configuration error, there can be malicious intent, right? So we cannot just believe that, okay, we cannot just keep on accepting the invalid routes, right? And not found is something you don't know whether that's valid or invalid. So you can develop your policies, right? So depends on like the state of the prefix itself. You can develop your policies and what do you want to do with those prefix. So generally the big providers nowadays are rejecting the invalids, but for the small providers, actually you don't want to disrupt your services, right? So maybe you can give a very low preference as compared to the not found and invalid prefix. So yeah, we have a prefix 6520. We have a row object 65420, and the prefix is 10.0.0/16, and the max length is 18. That's what we define in the row. Now, what is the let's see, like we see the route at 65420, prefix is 10.0.0/16. What can be the RPKI state? Right? Okay, so again we see 65420, 10.0, 128.0/17. Valid? Right? Correct. And 65421, 10.0.0/16. Why? Okay. And 65420, 10.0.10.0/24. Why? The max length is exceeding, right? So we have max length only up to 18. And 65430, 10.0.0/8. Invalid? Found, right? Because we have not created a row for it, right? And we only cover from 16 to 80. And so there is actually no row for this particular prefix. So it's marked as not found. Yeah, so if you have downstream customers or run a route server like an IXP dots, Internet Exchange Point dots, you can actually tag those prefixes with some communities, right? And propagate it to your peers. And say, for example, like when you do some kind of tagging, community tagging, you can just send that community to your BGP peers, and it's up to their decision to what to do with that community prefixes, right? So based on the values they see here, this combination, they can influence their routing decision, right? So according to the RFC 7115, it tells that the valid has to have the most uh, uh, preference, right? And basically the invalids have the least preference. So we're basically giving very low preference to the invalid routes, right? So yeah, there are a few providers we actually are dropping the invalid routes. So it's time for us to be everyone on the same page and at least have our ROAs being created, right? So that we don't fall under this group, right? So we announcing something with no ROA on the internet means it's going to be dropped at somewhere at some last provider's end. Right? So we don't want to do that, right? So we need to have ROAs in place at least, even if we are not doing validations. Okay, so another question is, are ROAs enough? Yeah, it works well, right? So we can just tell the origin AS number, the prefix, right? But on the BGP, we see different paths, right? So again, it's possible to force the AS path itself, right? So you can just insert some few AS path. The origin remains the same, the prefix remains the same, and again, there is a problem, right? So you can just manipulate the AS path. It goes through the validation row because it has the origin AS number is the same, the prefix length is the same. It's going to be accepted, right? So which means we need to secure the AS path as well, and we can actually use RPKI certificate for this, right? So we can use the same system for doing the AS path validation as well. So yes, there is a certificate authority, right? So there is a CA. I have this prefix, and that's I have a public key, my resources, and this is being signed by my CA, right? So now on my resources, what I have is now an additional thing over here. This is basically the AS number along with the router ID itself. So in the AS part, you basically see like the AS numbers, right? So the AS number belongs to one particular router on the internet because that's the one that's doing the routing, right? So basically, you can also encode the AS number together with the router ID. Now you have the prefix row as well, and you have this information as well, right? So these are called AS keys. right? So every router has one AS key. So whatever update it sends to its neighboring AS number, it signs those updates together from using that AS key. Now the receiver actually can use that information that's been publicly available and validate that, okay, this is the right update and this is the actually the router that's in the path, that has to be in the path, right? So yes, as an example, we can see like AS1, AS2, AS3, AS4. So AS1, you can use its own key and sign the updates it sends to router 2. Router 2 also can use the same updates, right, to AS3 and AS4. Now, yes, so AS1 crypto signs the message to AS2, AS2 router signs the message to AS3 and AS4. That's basically encapsulating all the previous messages from all other routers in the past that came before it, right? So now a BGP speaker can validate this information like first, there has to be a ROA for that prefix, that's correct. And second, if the received AS path can be validated on the chain of trust, right? So we have that AS key that also can be validated up to the chain of trust. So now we can validate the ROA itself, we can validate the router key itself, right? So now we know that, okay, the ROA is good and the updates I receive from a particular router, that's from my previous router on the path, it's actually a good update because I'm using its AS key to determine, okay, this update came from a legitimate router in the path, right? So one of the problems with the BGP sec is still new, right? And we cannot have this parcel adoption, right? So we cannot jump across participating network because we have that path information, right? So every one on the path needs to be cryptographically verified in order to implement this BGP sec, right? And other thing is resources, because like the internet has so many paths. Even for one particular prefix, as we talked, we cannot have a single reference point of view, right? So one prefix can have like multiple paths on the internet, and for every path you need to be able to validate. Means like you are buying more CPU on your routers, right, and more memory. So that's one of the problem. And again, there is also problem with the distribution of the collection of certificate itself, like how we want to keep that, right? Because again, I said like we do not have one single reference point of view, right? Okay, so this is another aspect. There is AS path uh, authorization. So basically, if you are a provider, you have your own customer set, right? So as a provider, you can tell that, okay, hey, these are the list of AS number that actually needs to be in the path, and you sign that object, right? Just like your route object, you can just publish it on the database. Now, so for anyone to do an check, like the AS path authorization is the attestation that the customer AS number has an authorized set of provider ASN to propagate its announcement, right? So a customer also can have its like set of providers that can actually route its announcement to the internet, right? So if I am a customer of some network, I have multiple providers, one AS number or to another AS number. So I can tell that information like AS2 and AS3 can actually announce my prefixes, right? So that's basically an attestation, right? So if there is an AS with the customer AS, and if it falls in that sequence, like the set, then it's actually can be validated, right? Else it's invalid. So if it falls within that set, means it's valid. If it doesn't fall within that set, means it's invalid. Right. So this is still a draft. It's actually not being implemented, as far as I know. But this is one of the things that simplifies the problems with uh, the AS path security. Right. So I think this is the last slide for this. So there is more reading, and if you are able to download the slides, then there are some links down below that you can follow along and be able to get more information. So, any question? Oh yeah, yes. Any gift? Anyone who wants to gift, you need to ask questions. Nice.
So
So well, it's like say for example, you have a set of prefixes, right? So you get us some prefix /20 say, right? And you're announcing like up to /23. Then you need to actually have the ROA information for all those prefixes. Whatever you announce on the prefixes, you need to have the ROA. Then only it will be someone doing the filtering based on the RPKI system, using the RPKI system would be able to verify that you are the actual resource holder of that prefix. And whatever you're not announcing on the internet means like, say for example, the internet exchange point lands, they generally don't get announced on the internet. So they have to come with like AS0. Like so anything that's seen with an AS0 origin means like it's not to be announced on the internet. So you can just reject it. So basically, you're announcing, like the sub prefixes you basically announce in order to influence the traffic flows, right? Say because BGP always work on like longest prefix match, right? So if you announce a more specific prefix, means like you're preferring that particular prefix on the internet, right? But yeah, I mean like like the size of the internet routing table, it's getting bigger and bigger every day, and it's always recommended that you aggregate your routes on the edge, right? But at least like if you're announcing some other routes belonging to that particular prefix on the internet, means like someone if you're not creating ROAS, then someone can actually hijack that prefix, right? Yeah, that's actually used also for load balancing, like so yeah.
It's like market doesn't or regular arbitrary. Cheap without site one or site two because we have the new maybe they have the dates number. If you have a large address block and then you announce, all your slash 24 with the same, AS path and things like that, you guys it's better to activate it. But if you have like truck engineering requirements, your slash 24 will be going through the AS path, then you have valid reason not to do the activation. I have a question about the ASPA validation that you mentioned on your last slide. Do you want to bring up the slide again?
Yeah.
Keep going. I'm looking at I wanted to make sure I understand. Seems like we're validating only the path between two ASs, right? We're compared to BGP sec where we cryptographically sign the entire AS path. Seems like ASPA we're kind of doing one hop by hop, right? Do I understand that correctly?
So yeah, I mean, like you're a customer, right? You have multiple providers. You can tell them that you can have that object, like just like the route object. You can tell it these are the list of providers that actually can propagate my routes, right?
Right, but then what about the upstreams for those providers? So say the third provider, the tier one provider, how do they validate that their downstream provider is allowed to be in that AS path?
Well, actually, this is just a draft, but what I think is like, like this set gets bigger and bigger as you move up to the right top, right? So this is one of the problems I think that's still in draft and like how it's going to be realized.
What's the I guess the prognosis for when do you think this is going to become widespread as a internet standard, or is it just kind of so far just in development and
I
wait
think
and see?
I think this is just a wait and see, right? So they're actually even BGP sec is like still has a lot of problems, like when it comes to small providers, like how we're doing, how they are trying to do this BGP sec validation itself, because the number of resources and when it comes to scaling itself, it's quite difficult, right? So it's not been fully adopted. And as far as ASPA, I don't think we have anything in the near future, but still there's a lot of work being done on it.
I think we're still trying to adopt RPKI, and it's a challenge too. So. Sorry, I forgot to introduce myself. I'm Jim from APAN. Um, EBN talk a lot about ROAS, and of course, we encourage you all to create your ROAS for your matrices or your address blocks. But bear in mind that you need to keep your ROAS up to date. Otherwise, you create more problem than the solve problem. So if you have any network changes, please make sure that your ROAS modified and changed accordingly. So it's a continuous effort, not just one off things. That's all I want to say.
Okay, so we still have 15 minutes more, right? But before we go into the break, I actually want to show you like the labs we are trying to access for this rest of the session, right? So one of the things is I already talked about it earlier as well. If you go into your agenda and see, there are a few other labs that you can use, right? So this is the first lab that we are going to use. We are using the fourth validator. So what we are trying to develop is like we have a small integrated network with routers and validator. So we're trying to build a validator, and we're actually doing a small lab to see like how validation works, right? So for you to be able to access this lab, you need to be a user in the Ethnic Academy system, right? So I hope everyone is already a user. If not, then you can just register yourself as a user now, right? So you can just click here and register, right? It's very simple. It's 2 minutes. So I already have a user here, and so and it's not working right now. But I hope everyone is able to follow all of this one. Skip for now. So I am logged in already, right? So on this menu, you have this virtual labs. But let me tell you a slightly about other things on this page. So we have a course catalog, and there are some online courses that you can follow along, right? So these are the courses that you can do self-paced, and you also will get a certificate on the completion of these uh, online courses, right? So right, so I suggest you to have a look around the page and follow some links, right? So there are actually a lot of activities and materials that we as Epinic do for this Epinic region, and it's actually an archive of like all the activities we do as training programs, and you can follow along those links and get yourself used to it and get some knowledge out of it. Right? So, goodbye. And we also have this information like how these routers are connected to each other. These are just point-to-point links /30, right? And this is all for the instruction, right? So it's very simple lab. So we have three routers, one validator cache, all connected to each other, and all of these routers are going to fetch the information from the validator cache and doing the validation. Right. So this is what we are trying to do as lab this afternoon. So for you to be able to access, you can click on the right hand side. There is a resource menu, right? So you can just click on one of this VM. So now I'm already into this VM. So I'm in this Ubuntu VM, right? So if you want to go to the router, you can just click on it and it will prompt another command line interface for you. So this is basically a router. Right, so still loading maybe. And for router 2, also the same. It's loading. And similarly for router 3. So if you have to work on this, you just need to click on this and you have to come to this side, move your cursor here, and then start doing your commands, right? And on the instruction sheet, you can actually save your lab, right? So if you're not able to finish it today, you can just go here and click on this menu, then you can save your lab, right? And this lab is going to be run for like 2 hours, right? So before 15 minutes, it will actually prompt you if you want to extend some time. Then you can just extend the time and you can use the lab again, right? So you can just continue from the same point you are. And so click on next. So first part is RPKI validator. So we are installing the Ford validator. Ford validator is an initiative by LACNIC and Nick Mexico, right? So there are all the instructions that has been given to you in order to install the Ford validator, right? So all of these command line commands, they actually work and have been tested several times, right? So I think it won't be a problem. So once you install Ford, right? So once you install Ford, then you should be able to see this RUA payloads, right? So they're actually stored somewhere, and you'll be seeing like how they are organized in that file itself, right? And the first part is the RPKI lab with Ford, right? And there's another validator, that's the routinator, right? So it's written in Rust and developed by NL Labs, right? So we are actually installing two different validators here, right? And the reason is like it's always good to have this redundant validators in a system, right? So your router talks to like two different validators at the same time. Why? Because you need to be able to have the complete information, right? So that's one of the things. And also like if for some reasons the router and the validator system fails, then every prefix would come as invalid if you are using only one validator, right? So this is one of the reasons we use two validators. So it's also very simple. You can just follow along this instructions here, and you should be able to get similar output on the screen, right? So once you do that, oh, there is another one. There's RPKI client as well. So you can do this one as well, right? So um, this is also very simple. You can just follow along. And on the last part, we actually do some configuration on the router, right? So we basically set up a BGP session between the participating router on the network itself as well as the validator, and we're trying to check the validation state, right? And with the validation state that we obtain, what are we going to do, right? What kind of routing decision we are trying to do? So this is the lab that you'll be doing in the end of this session, right? So basically, you're trying to create a rules like say local preference, how you are going to set it in two different format of OS like Cisco iOS and Juniper OS, right? So this is it for today's lab, and I think most of you will be able to follow along the lab, and I will also actually be doing demo once you guys get used to it and follow along the lab. So after maybe an hour or so, I can just do a slide demo on running one of the validators as well as configuring the sessions between the validators and routers and what we are going to do with the validation states. All right. So the first thing is like you need to be able to see this pop-up screen. And actually, I have few of my colleagues who can help you out, like setting up this interface on your screen so that you can be able to follow the flaps. So if you have any questions, please let us know.